forward. So here's the deal. If you have a question, stop me, okay? Please. All right. So Monday, for some reason, seems like ages ago, we started talking about exponential functions. And just to kind of recap where we left off, so we saw that exponential functions have the form a times b to the x. A is our initial value. Okay, in other words, it's our function value when x is equal to what? 0. And b is our growth or decay factor. And we saw that if b is greater than 1, it's growing. And b equals 1 plus whatever the growth rate is. And if b is between 0 and 1, there we go, it's decaying. And it's 1 minus whatever the decay rate is. So we played with various examples here going through this. And the last example that we went through was that car purchasing business for that depreciation. Okay. So the question is that we kind of left off with is, what if we're not given our initial value directly or our growth or decay rate directly? Okay. It's kind of like, remember when we were studying lines, y equals mx plus b? If I told you what your slope and your y-intercept were, you knew the equation of the line, right? Like if I told you, hey, your slope is 5 and your y-intercept is 7, what's the equation of our line? Y equals 5x plus 7. Sweet, we were given those directly. Kind of like what we were given with our exponential functions on Monday. But it was a different kettle of fish if I said, hey, find the equation of a line that passes through, you know, who cares what ordered pairs, right? Then we could still find the equation of our line, but didn't it take more work? Because first we had to find our slope, right? And then from our slope, we would plug that in for m, and then we would plug in one of these ordered pairs to find our y-intercept. Okay, so when you're given the information directly, life is pretty sweet. Okay, when you're given the information indirectly, hopefully life is still pretty sweet, but it's going to take more work. Okay, so that's the situation that we're going to start tackling now with our exponential functions. Okay, so specifically, one second. What if now I ask you to do the following? And this one's still pretty chill because we might as well start out, you know, without going for the gusto. Okay. What if I ask you to find the equation of the exponential function y equals a times b to the x if it passes through two ordered pairs, 0, 6, and let's do 3, 750. Now I claim that this one's actually nicer than some of the others we're going to be doing, okay? So just like when I asked you to find the equation of a line, we would write y equals mx plus b. We need to find m and we need to find b. Now, when I ask you to find the equation of the exponential function, I want us to find y equals a times b to the x, and we need to find our value of a, and we need to find our value of b. You with me this far? I claim we're given one of them. Okay? You might not see it directly, but I claim that we're actually given our initial value. Okay, good. It's 6. Okay, so this is something you want to be on the lookout for. Do you agree if I plugged in this ordered pair, I'd have 6 is equal to a times b to the 0 power? And what's anything raised to the 0 power? 1. So don't we get a to be 6? So already I know I have 6 times b to the x power. Now, how do you know to look for that? Remember, your initial value is your function value when x is 0. So when you're given this ordered pair, hopefully your eyes are going to light up a little bit and be like, cool. You with me this far? Okay, well, we found one of our unknowns. We got to find b. Well, what can we do to find b? What other piece of information are we given? Aren't we given another ordered pair that this thing goes through? So why don't we plug that in? Why don't we say, well, when x is equal to 3, my y is equal to 750. You see how I plug that in? Okay, it's important to plug in x, y values. All right, well, we want to solve for b. Let's do some algebra here, okay? What's the first thing we're going to want to do in order to solve for b? Be careful, you got the right idea, but notice I'm multiplying by 6. So what do I have to do? Divide by 6, right on. So on my left, I'm going to get 125. And on my right, I'm going to get b cubed. Trust me, 750 divided by 6 is 125. Okay, but I don't want b cubed. I want b. How do I undo cubing? Close the cube root. Yep. So what I'm going to do is I'm going to raise both sides to the 1/3 power. If I was squaring it, yes, I would take the square root. If I was raising it to the 5th power, I would take the 5th root. And I claim, so notice on my right, when you raise something to a power raised to another power, you multiply your exponents, and 3 times 1/3 is 1. And the cube root of 125, I'll tell you, is 5. So the equation of this exponential function is 6 times 5 to the x. So my base 5 is called my growth factor. That's my b. What I want to know is, what is your growth rate? Remember how we were playing with this last time? When you're growing, isn't b equal to 1 plus r? What's my b here? 5. So what is r equal to? 4. So what is my growth rate in percent form? Change 4 to a percent. You're changing it the other wrong way. You go 2 places to the right. It's 400% growth rate. And we hope it's not a nasty bacteria or virus that's growing that fast. You with me this far? Okay. All right. So this is kind of the nicest of those situations because we were given one of our values. It was just kind of disguised. Okay. But now let's get a little more quote unquote interesting. Suppose now I want us to find the equation of the exponential function y equals a times b to the x that passes through the following ordered pairs: -3, 4 and +3, 2. Now what I'm going to do is set this up, and then I'm going to write out formally the steps that you're going to use to solve these things. Okay? Because this is yucky. Like there's just no way around it. Okay? And these steps that we're going to use to solve these, have in front of you when you're doing these exercises. You will learn these steps with practice, but don't expect yourself to remember the steps right from the get-go. Okay? You're going to put yourself in an uncomfortable position. Okay? So notice I'm given 2 ordered pairs. I could say, well, I could plug my ordered pairs in for X and Y, couldn't I? Right? This is my X, this is my Y. So I could say, well, 4 is equal to A times B to the -3rd power. And if I plug in this ordered pair for X and Y, don't I have 2 is equal to A times B cubed? I first want you to think about how we went through and plugged in these ordered pairs. I want to make sure you're cool plugging in the X, Y values. Do you all see how we did that? Okay, awesome. Okay, well, we're kind of left with like, well, what do we do from here? Okay, so now what I'm going to do is I'm going to write out the steps on another sheet of paper, and we'll have these with us. Okay, so step 1, this is when you want to find the equation of an exponential function and your ordered pairs are not very nice. Plug in your ordered pairs. Do you agree we did that? Okay. Now what I'm going to do is I'm going to tell you to solve, but I'm putting in quotes, solve, because we're not going to get an actual value. One of those for A. Now, I have a preference with how I do it. You don't have to pay attention to my preference at all, okay? But I tend, when I say solve for A, what I'm saying is isolate A. We want A equals some expression, okay? Now, I tend to pick the one with the smaller exponent. In other words, the smaller X value. That's just my preference to do, okay? So this is where our properties of exponents are going to come in loud and clear. When you have a negative exponent, do you agree to make it positive? You bring it down to the denominator? Remember our properties of exponents? Okay, I want to get a alone here. The issue is I'm dividing by b cubed. How do I get rid of this b cubed down here? Multiply both sides by b cubed. Very good. Do you agree then I have 4b cubed equals a? And I'll write in here, I tend to use the smaller value of x. That's the one that I tend to isolate my a with. So do you agree that if this ordered pair actually lives on this exponential function, it's got to satisfy a equals 4b cubed? Okay. Well, step 3. Substitute that value for a into the other equation to solve for b. So if a has to be equal to 4b cubed, what I'm saying is plug that in for a over here. If I do that, don't I get 2? In place of a, I write 4b cubed. And then I have this other b cubed, right? This is my a, and that's the b cubed. Do you see how I plugged this in for a here? And then I had this b cubed. All right, now we got to solve for b. Well, first we got to clean this up a little bit. When you multiply two things with the same base, what do you do to your exponents? You add them. So what do I have? B to the 6th power. Can I solve for b? Yeah. What's our first step in isolating our b? How do you undo multiplying by 4? Divide both sides by 4. Well, 2 over 4 is 1/2, and that's equal to b to the 6th. I don't want b to the 6th, though. I want b. So how do I get b alone? Raise both sides to the 1/6 power. Okay? Because b to the 6th to the 1/6 is b to the 1st. What we need to compute is 1/2 to the 1/6 power. And this is where calculators are super. Okay? So I'll show you on this calculator. I want to find 1/2. And normally, yes, I would just plug in 0.5, but I want to show you every little step. So 1 divided by 5, or excuse me, I can do this, I swear. 1 divided by 2. I was thinking 0.5, that's why I put in the 5. And then I want to raise that to the 1 divided by 6 power. Okay? And you get this. Now I'm just going to go to 2 decimal places. So do you agree I get b is 0.89? Is this growing or decaying? Decaying, good. So essentially what you plug in your calculator is this. That's how you raise it to the power, just in case you didn't know. Hey, we found our value of b. Isn't that awesome? So at this point now, don't I have y is equal to a times 0.89 to the power of x. So one last step. We need to find a. So what you do is you plug in b to the expression found in number 2 above. Remember how we got a by its lonesome in terms of b? Right? Didn't we have a is equal to 4 times b cubed? Isn't that the expression that we found that we substituted in the other one? Well, now we have b is 0.89. So can I find a? How? You got it. You got it. Remember, in number 2, we solved one of those for a. And what we had found was that a was 4b cubed. Well, now we know b is 0.89. So a is 4 times 0.89 cubed. And if you do this computation, you're going to get about 2.82. You with me there? Don't worry, that's not the only one we're going to do. Are there questions this far? Now, what we're going to do is take these steps and we're going to do another one. Now, what I want us to do is find the equation y equals a times b to the x, in other words, of the exponential function that passes through the ordered pairs. How about 2, 5 and 6, 9? All right. Here's our steps. What do we do first? Plug in x and y. So if I plug in x and y, notice x is your exponent, y is the value over here. Don't I have 5 is equal to ab squared? And then 9 is equal to ab to the 6th? You with me this far? Okay. Now what we want to do is we want to isolate a. And again, I tend to do it with a smaller exponent because I think it makes the end computations a little bit easier. So how would I get a alone over here? Divide both sides by b squared. So do you agree a is 5 over b squared? You with me this far? Okay. Now, what do we do with that? We substitute that value for a into the other equation to solve for b. So if I do that, I get 9. In place of a, I'm going to put 5 over b squared. And then I got that b to the 6th. You with me this far? Okay. Got some properties of exponents happening here. I'll savor my left-hand side 9. I got my 5. What is b to the 6th over b squared? When you divide two things with the same base, what do you do to your exponents? You subtract them. Remember how I told you you got to remember your properties of exponents here? This is where they come. So don't I have 5b to the 4th? All right, I want to solve for b. What do I do? Divide both sides by 5. So do you agree I get 9/5 is b to the 4th? But I don't want b to the 4th. I want b. How do I get b alone? Raise both sides to the 1/4 power. In other words, if you were putting this in your calculator, in case this helps you at all, 9 divided by 5 raised to the 1 divided by 4, or you could just put 0.25. So if I do that, 9 divided by 5, and I raise that to the 1/4 power, and I'm going to go 2 decimal places just because that's kind of my mode. Do you agree we get b is 1.16? All right, now thus far we have a 1.16 to the power of x. Now we got b, we now need to find a. But this is where I say, take that value of b and plug it into that expression for a that we found in terms of b. Don't we know that a is 5 over b squared? So 5 divided by 1.16 squared. And that's about 3.72. And there's our function. You with me? It's a lot more work, isn't it? I'm not even going to say it's a little more work. It's a lot more work. Okay. You ready for another example? Are you having fun? Oh, do you want me to? Sorry. Yeah. Sorry. I just get overexcited.
I got it, and appreciate it.
No, I appreciate you calling me out on that. All right. So same type of problem, but it's going to look a little bit different now. What if I tell you that we are going to start some experiment with 100 milligrams of some such thing? And after 35 hours, 50 milligrams of that substance remains. And then I want to know, okay, how many milligrams remain after 54 hours? And assume exponential. So I'm starting to want to tweak us over to word problems now. Okay. And again, I'm trying to start out a little bit chill here. All right. Well, I'm not even going to go to answer this question until I find my exponential function, okay? So my first step is to say, okay, y equals a times b to the x. We're told it's exponential. Let's find our values of a and b. We're given some information, aren't we? I claim we're actually given two ordered pairs. We're starting with 100 milligrams. So if I wanted to write that as an ordered pair, it would be 0, 100. And what would then be my other ordered pair? 35, 50. Now, why am I particularly excited about this first ordered pair? We do have the A value, right? We're given our initial value. That is a cause for celebration. Can I find my B value? What can we do to find B?
Put 35 and 50 in the equation and solve for x.
You got it. Or solve for B.
Solve for b.
Yeah. So we're going to say, well, y is 50 when x is 35. What would be my first step in solving this equation for B? Good job. We would divide by 100. So we're going to get then 1/2 is b to the 35th power. We don't want b to the 35th power. We want b. What do we do?
Raise both sides to 1.
Yes. We take the 35th root of both sides because it's such a common thing to want to know. So essentially, you're going to take 0.5 raised to the 1 divided by 35 power. I claim you're going to get b to be about 0.98 if you go to 2 decimal places. I did the computation already. I did not do that in my head. Notice it makes sense that our b value is less than 1 because isn't this decaying? It's always good to be like, does that make sense? So I now know that I have 100 times 0.98 to the power of x. Have I answered the question that we were initially asked? Not yet. We were actually originally asked, okay, how many milligrams remain after 54 hours? So what are we going to do with that 54? Well, the hours was my x value. Won't we plug in 54 for x? So we're going to plug in x equals 54. And if you do that, you're going to get about 33.6 milligrams. You with me there? Are you all okay so far? You sure? Okay. So don't worry, we're in this section for a fair amount of time. We're going to get a lot of practice, but now I'm going to still talk about it. Just kind of change the angle. Okay. So my next thing is as follows. Oftentimes we're given some data set. And we're asked to determine if it's best approximated by a linear function, an exponential function, or neither. So if you're given a bunch of data, how can you tell whether it's linear, exponential, or neither one of them? I mean, there are, you know, a ton of different sort of functions, so. Okay, well, how do we know that something is linear? Isn't the hallmark of a linear function is that it has a constant rate of change? You agree? I mean, that's the hallmark of having a linear function. In other words, if the difference between consecutive terms is constant. i.e. the slope is constant. And for what it's worth, we say that our slope then is the common additive term. On the other hand, we know we have an exponential function if it changes by a constant percentage. And so we say if the ratio, i.e. divide, of consecutive terms is constant. And we call that our common multiplicative term. And this is more terminology than you're necessarily going to want, but I think it's important. So what I'm going to do now is go through a 1, 2, 3, 4, like 5 different data sets. And I'm going to ask you, are these linear, exponential, or neither one? And it sounds more complicated than it really is. Okay, and I don't know if we'll have time to do all 5 of them today. We'll just take it as it comes. Tell me when you got this written down though. Cool. All right, so let me start out with this first one. And I'm just making these up, okay? Well, there is some rhyme or reason because I'm trying to make a point. So all I'm asking is g of x linear, exponential, or neither? I always check linear first. Okay, so my first question I'm going to ask myself is, Lauren, is this linear? Well, this goes back to the first question on that quiz that y'all just recently took. Okay, notice our x's are changing by the same increment. Are our function values also changing by the same increment? Well, how do you get from 40 to 32? You subtract 8. To go from 32 to 26, what do you do? It's 6. So is this linear? Do we have the same slope? No. No way. Not a constant slope. Right? If you find the slope of the line between these two ordered pairs, it's going to be -8. If you find the slope between these two ordered pairs, it's going to be -6. So this is not linear. You with me there? All right. Now let's ask ourselves, is this exponential? What you do to determine exponential, and it was a lot of words here, is you look at the ratio of consecutive terms. So remember, with linear, we looked at the difference between them, i.e. subtract. Now we're looking at the ratio. In other words, is 32 over 40 the same as 26 over 32? The same as 22 over 26? So do you see what I mean by ratio? Ratio means divide. So you take the second one divided by the first one, then the third one divided by the second, then the fourth divided by the third. Well, what is 32 over 40? Good job, 0.8. What's 26 over 32? 0.8125. Are they the same? Almost, but close. What did they say? Close, but no cigar. Yeah. So, nope, it's not exponential. They have to be exactly the same. So, this one is neither. And I wanted to start out with one that's neither, just because most people expect to get one or the other on the first round. You ready for another example? What if now I have this one? And again, I'm wanting to know, is this linear, exponential, or neither? Well, again, I'm going to start out with linear because for me, that's the most natural and easiest one to check. Well, notice our x values are changing by the same increment, so we just need our function values to be changing by the same increment. How do you get from 40 to 32? You subtract 8. How do you get from 32 to 24? You subtract 8. Whoa, we're on a roll. It just has to work this next time too. How do you get from 24 to 16? You subtract 8. Woohoo! Is this linear? Yes. Yes, it is linear. Well, since it's linear, I can't help myself. Let's find the equation of the line. What is this -8 that we found? That's our slope. Notice we're not given our B value. We would know that we were given our B value if we had our function value when X was 0. But we got 4 other ordered pairs that we can plug in to find B. I'm going to just plug in the first one because I like to do the easiest computations. So do you agree we say Y is 40 when X is 1? So what's my B value? 48, right on. And we only have 3 minutes left, and so I'm just gonna say, I've got 1, 2, 3 more examples that we're gonna do on Friday. Are you okay with this so far? Okay. Well, thanks. I appreciate y'all. See ya, Alex.